we're able to do, and all of our operators are cross-trained, so they can do the small turning and large turning. We do try and operate in cell technology, so one operator can operate multiple machines at one time. That's really helped us keep up with the throughput and the massive growth that Seakeeper is going through right now, year after year. Solid slug comes in this way, and we'll turn all the grooves, we'll mill the holes, everything right here in this room. We also have castings like you see on the pallet back there. At one point when we were first started off, that would have been made out of one solid block like this. We've taken the time and the investment into the tooling now, and they'll come in as aluminum casting for us. Everything's turned 100% in-house. Most of the gyro is aluminum. The gimbal shafts we showed you and the flywheel, as well as a couple other small round parts, are going to be steel, but almost everything else on it is aluminum, whether it be cast or solid bar. When we show you the SK3, you notice we're able to remove the fins as we get smaller here. Lighter weight, just great cost saving for us and for the end product. As we get smaller and smaller, weight's becoming even more critical for us to find ways to take weight out of the product. And it's tough when you're dealing with an aluminum product that's already, about as light as you can make it, right? So all those little, small details that our engineers are able to find out and how to revamp on the next model for us are paying dividends for us. On basically these four pieces of equipment right here, we are turning and milling all of our flywheels for the Seakeeper models. Every single flywheel we have to grind for bearings and motor. We're grinding on the shaft on two locations, on this side and this side. So the flywheels are turned and milled in the other room. They're brought into the back room here, and every single flywheel is precision ground on the shaft for bearings. We're looking for any sort of cracks or materials that either happen during the forging process or happen during the machining process that we can expose. So every supplier has kind of asked us, do you really need to do that? And the answer is yes, we do. And it's just that extra quality level that we're trying to ensure that what we're putting out there is 100%. We cannot afford a single failure in the field on this because of this. Every single one of our gyros comes through final assembly testing. So we custom designed these tilt tables, and we took a program from one of our owners, John Adams, where we actually take a real life sampling from a boat in the, I think it was the Northern Sea during a storm. That wave profile is about the worst conditions that our gyro could ever see. And we run every single one of our gyros through that exact same profile here. It's about a 5 or 6 hour program. Load the table, run it through, do everything you need to do, and otherwise take about a shift to do each one. So what the table is simulating is the roll of the boat. The gyro is doing exactly what it needs to stabilize it, and we're recording all that data for every single gyro, and we are storing that. So we have the history of that, and also we're able to identify what the problem was, if there is a failure, a noise, vibration, whatever that may be. So we maintain a high level of spare parts inventory here. We ship directly from the factory here to one of our sales and service hubs, or direct to the boat itself, whatever the case may be. This is all controlled in-house by our guys.